Hello everyone, good evening. So here we shall explain some proofs of some of the theorems on the quadrilaterals. So here in the here in this theorem, it is told that the diagonals of a parallelogram bisect each other. So we have to prove this. So first we will draw a parallelogram. Say it is a ABCD, and we have to say that we have to prove that the diagonals bisect each other. Diagonals bisect each other. So first we have to write what is given. Given is that AC and BD are diagonals of a parallelogram ABCD. A parallelogram ABCD which intersect at the point O, which intersect as O. And then we have to prove that the diagonals AC and BD bisect each other. AC and BD bisect each other. That is, we have to show that OA is equal to AC, is equal to half of AC, and also OB is equal to OD, which is equal to half of BD. So that we have to prove. So the proof is like this. You have to consider two triangles. So I will take in triangle ACD and triangle CAB. ACD and CAB. Angle ACD that is equal to angle CAB. Since obviously alternate interior angles are equal, so hence we can say that CAB equal to AC. Since as we can say as AB is parallel to DC and AC is the transversal, and you can also see that this angle will be equal to these angles, which means angle DAC that is equal to angle BCA. Since alternate interior angles are equal, its alternate interior angles are equal as AD is parallel to BC and obviously AC is the transversal. And also you can say that AC is the common side. AC is the common side. So therefore I can say that this triangle ACD is congruent to triangle CAB by, here we have taken two angles and the included side. So these two are congruent by the ASA rule of congruency. By the ASA rule of congruency. The ASA rule of congruency. Therefore, we can say that triangle ACD is congruent to triangle CAB. So therefore, I can say that AD is equal to BC and AB equal to DC. So I can say AB equal to BC. AD equal to BC. CPCT. So basically, these two sides are equal. You can see that in triangle OAD, and triangle OCB, you can say that angle OAD equal to angle OCB, since alternate interior angles are equal. And AOD is equal to COB, angle AOD is equal to angle COB. Since vertically opposite angles are equal, these two angles, vertically opposite angles are equal, and you can see that AD equal to BC, is proof above, they are proof above. So therefore, I can say that triangle OAD is congruent to triangle ACB. AD is equal to BC. So we have taken two angles and the side, which is the non-included side. So therefore, these two triangles are congruent by AAS rule, of congruency. By AAS rule of congruency. So therefore, now we can say that OA is equal to OC. So now we can say that OA is equal to OC and OB is equal to OD. OA is equal to OC and OB is equal to OD by CPCT. 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 So therefore, we can say that OA is equal to OC and OB is equal to OD by CPCT. So therefore, we can say that the diagonals AC and BD bisect each other. So hence, then here it is told the diagonals triangle ABC. If you take a triangle ABC and the line is drawn to the midpoint of one side, let's say the midpoint of AB is D, triangle ABC, and a line is drawn parallel to this BC, which intersects the third side. Let's say at the point E. Then we have to show that E is also the midpoint of AC. How to prove it? We will draw a line through C, which is parallel to BA, which intersects TE extended at BF at F. So first, we will write what is given. So given is that first is D is the midpoint. D is the midpoint of the side AB of triangle ABC, through which a line is drawn, parallel to BC, which intersects AC at E, intersects AC at the point E. Then we have to prove that E is the midpoint of AC. E is the midpoint of AC. Or we can say that we have to prove that AE is equal to CE. Then we will write construction is that to the point C, a line is drawn parallel to BA. Line is drawn parallel to BA, which intersects DE extended the proof. The proof is that quadrilateral DBCF D is parallel to CF since construction is parallel to BA construction, and BF it is given that through D a line is drawn parallel to BC which intersects AC at E. So hence it means it is equal to BC. So hence we can say BC is a parallelogram. BC is a parallelogram since its both pair of opposite sides are parallel to each other. Which sides are parallel to each other. Therefore, So therefore, we can say that DF equals to BC, DF equals to BC, and of course, DB equals to CF. Since why? Since in a parallelogram, the opposite sides are equal to each other. Since in a parallelogram, the opposite sides are equal. The opposite sides are equal. AD is equal to B is equal to B since even the midpoint of side AB. Now AD is equal to B, and so we can say is equal to B is equal to B is equal to F. So AD is equal to F. So now therefore in triangle ADE, and triangle CFE, EFE, you can say that angle AED, that is equal to angle CF, since vertically opposite angles are equal. This vertically opposite angles are equal. And we can say that AD is equal to CF, AD equal to CF, which is proved earlier or proved above, and angle AD, equals to angle CF. CF is simply CF is parallel to BF. CF is parallel to BF, and obviously BF is the transversal. So therefore, we have shown that these two angles are equal, and these two angles are same, and these two sides are equal. So hence, the two angles and the non-included sides are equal in these two triangles. So by KAS rule of congruency, these two triangles are congruent. So therefore, I can say triangle ADE is congruent to triangle CFE by angle side, or by AAS rule of congruency. AAS rule of congruency. AAS rule of congruency. The AAS rule of congruency. So therefore, we can say that. So we can say that now AE is equal to CE, AE is equal to CE, and also DE is equal to EF. So DE is equal to EF by CPCT. So therefore, hence we can see that therefore E is the midpoint of AC. So E is the midpoint of AC, as AE equal to CE, it is equal to half of AC. Since AE plus CE is equal to AC, so AE is equal to CE, so each of them are equal to half of AC. And also, you can say that DF is equal to BC, since it is a parallelogram. Also DF is equal to BC, since obviously opposite sides in parallelogram DBCF are equal. Since also we can say since it is proved above, and also DE is equal to EF. So DE plus EF is DF. So D is equal to EF, which is equal to half of DF, half of DF. So hence DE, we can say D is equal to half of BC. So hence proved that E is the midpoint of AC and also D is half of BC. So this is actually the converse of midpoint theorem, which we have proved. It is called the converse of midpoint theorem. I hope you understood the proofs of all these theorems. Still, any doubts if you have, please write that in the comments. So thank you everyone. Bye.